Hello, my name is Brianna Poulos. I work at the Johns Hopkins University Applied Physics Laboratory in Laurel, Maryland. And today I'm going to talk about image security and what you can do about it. I'll discuss a feature that has recently been added to Glance, along with what we plan to add to Nova, and also give a brief demo of this feature. So, first off, what is the normal image boot path in Glance? You have the user who uploads an image to Glance, along with properties about the image. Glance then stores this image, and then Nova later requests the image. Glance returns it, along with the properties, provided Nova requests the properties. Nova then verifies this image using an MD5 hash of the image, and then Nova boots the image, provided that that hash verification succeeds. With this approach, there are several vulnerabilities. For one, between when the user has it and when it uploads to Glance, it's possible it could be modified there. Also, when Glance is storing the image, that's another possible place for modification. And when Glance is transferring the image to Nova, that's another place that it could be modified. The problem with modification is if it's malicious, you could have malicious code inserted into your image. This could cause problems. So ideally, we can mitigate these vulnerabilities. So, what is signature verification and how does it help with this? Well, you have a sender, you have a receiver, and the sender wants to send data to the receiver, and the receiver wants to guarantee that the data hasn't been modified. The sender, using their private key, creates a signature of the data, and then the data along with the signature are sent to the receiver. The receiver can then use this signature to verify that the data hasn't been modified using the sender's public key. This is useful because nobody can create a valid signature unless they have the sender's private key. So this provides some guarantee to the receiver that the image hasn't been modified. And they can confirm. So in order to add this signature verification to the normal boot path, we have to add a key manager to this approach. The user creates an image, then creates a key pair, creates a certificate with this key pair, and then signs a hash of the image using the private key. The user uploads the certificate to the key manager, and then uploads the image data along with the signature metadata. Glance, seeing that the image has signature metadata, then retrieves the public key certificate from the key manager, verifies the image signature, and provided that signature verification succeeds, goes ahead and stores the image. Later, Nova requests the image from Glance and also requests the image metadata. And Nova, using this metadata, retrieves the public key certificate and then validates the certificate, verifies the signature, and then boots the image. And so with this approach, the user has a guarantee that the image has not been modified between when the user originally had the data and created the signature to when Nova then uses the image to boot an instance. So I'm going to give a brief demo to show this feature. A couple notes about the demo. I'm using DevStack with stable Liberty, except for a modification to Nova, which includes this feature. And also the key manager that is being used with this approach is Barbican. And if you're curious about this demo, you can see the instructions for it at the Etherpad listed there. I've uploaded these slides to the Tech Talk session, so you can access them there as well if you're interested. So first off, we start with a private key and a certificate. We store the certificate using Castellan into Barbican and get a certificate UUID, which can then be used to retrieve the certificate. And then we also retrieve the image. This is just a simple Ceros image, not very big. We create an MD5 hash of the image data. This is equivalent to the checksum that is stored for the image in Glance. And then we create a signature of this checksum using the private key that I showed earlier and encode this signature using base 64. And you can see the signature there. Then this signature, along with the certificate UUID, and various aspects about the signature, such as the fact that it's RSA PSS, are uploaded to Glance. Glance, seeing this information, verifies the signature, and you can see that no errors are returned. If we look at the log messages, we can see that the verification succeeded in Glance. And if we go into Horizon, we can take a look at the image, confirm that it's uploaded, that it's active. We can also look at the metadata that's associated with the image and see that the signature properties that we added are there. So you have the signature itself, the certificate UUID, the hash method, in addition to other characteristics that are needed in order to verify the signature. So if instead an incorrect signature is used, we change a 6 to a 7 in the signature and try to upload it to Glance, we can see that the signature verification fails instead of succeeds. We'll also upload an image that doesn't have a signature for use later in the demo. And we can look in Horizon and see that there is no signature metadata associated with this image. Moving on to Nova, we can look at the configuration flag in Nova. If this flag is set to true, Nova will only boot images that have signature verification succeed. This is to prevent somebody from just simply removing the signature metadata in order to bypass this security feature. So if we go into Horizon, go to launch an instance, we can choose initially to use the image that doesn't have signature metadata associated with it. So we choose to boot from an image, we choose to use the image that doesn't have a signature. Initially it looks like it's succeeding, but then we get a red box that says it failed, and you can look at the status and see that it's in an error state. Looking at the log messages, we can see that the reason that this failed was because the required image properties for signature verification don't exist. If instead we boot an image that does have the signature verification properties that are needed, then we can see that it succeeds. So we choose the image that has the signature, launch the image, and then we can see that it's a success, it's building, and then it goes into an active state. And if we look at the log messages, we can see that image signature verification succeeded for this image. Now, as to what's actually in Liberty at the moment, we have added the ability for Glance to verify signatures, but the capability for Nova has not yet been added. We intend to add it for Mintaka. Also, there are several improvements to be made to this initial implementation. For one, we're using the checksum that's in Glance, which is currently hard-coded to be MD5. Ideally, something other than MD5 will be used because MD5 is not cryptographically secure. So we hope to make this configurable so we can change it to something like SHA-256, for instance. Also, currently only RSA PSS is supported as a type of signature. We plan to add support for elliptic curve and DSA signatures as well. There's also a limit to signature size due to Glance property size limits, and we intend to increase that so that we can support larger signatures and in turn support larger key sizes. In Nova, we plan to add the initial implementation that has a global configuration flag that requires this signature verification in order to boot an image. We also plan to add certificate validation to Nova, and eventually add the ability for Nova to create signatures for snapshots as well. We also want to add the ability in Horizon to support signature creation and validation there as well. So, in summary, image signature verification guarantees that an image has not been modified between when an image is uploaded and between when the image is booted in Nova. And this approach improves the security posture of OpenStack. Thank you for your time.